Alright guys, welcome back to Underground Science, and in this video we'll start naming alkenes and talking about that, alright? So the best way to learn is, like we did for naming alkanes, let's just jump right into practice problems. Okay, so the first one we'll do, let's draw it in, it'll be 1, 2, 3, 4, 5, 6, 7, 8, and let's draw the double bond here, since it's alkenes now, right, which means double bond. Okay, so that's our example problem, and right away, what do? Right, like we did for the alkane video, or alkane naming videos, we numbered the longest carbon chain. So let's start. So what are two main ways we can number this, right, or the only two ways that make sense? 1, 2, 3, 4, 5, 6, 7, 8, and then the other way, right? So 1, 2, 3, 4, 5, 6, 7, 8. But which numbering pattern is right? So for the alkane video, what was the rule? You want the numbering pattern in which the carbon number, or in which the substituent is on the least carbon number. So if we had an alkane here and we had this, right, we would want to number it from right to left, because this way we have the methyl substituent, right, on the least carbon number, which is 2. Because if we numbered it from this side, we would have the methyl substituent on carbon number 4, which is higher than 2, so that's not the correct way to number it. Same thing goes for here, except you want the double bond on the lowest carbon number. So the orange numbering would be correct, right? Because if you look at the green numbering, the double bond is on carbon number 6. And the orange numbering, the double bond starts at carbon number 2. So the orange numbering would be the better numbering pattern. Okay, so if we drew the orange numbering, actually draw the actual numbering now, the correct numbering, right? 5, 6, 7, 8. We do the double bond here. So the correct numbering would be from left to right, because this would yield the lowest carbon number. This would yield a double bond on the lowest carbon number. All right, so we have the double bond on carbon number 2. All right, so whenever you have a double bond, right, in a molecule, let's say we drew this, and we numbered it 1, 2, 3, the double bond, or like what carbon number would the double bond be on? It's whatever carbon number that starts on the double bond. So we're going left to right, right? So the double bond starts on carbon number 1, so we would say it's on carbon number 1. All right, and that'll help us in naming too. Okay, so now we just name it. So how many carbon longs is the carbon chain? 8, right? So that'd be oct. And do we have a double bond here? We do. So it wouldn't be octane, it would be octene. Okay, and on what carbon number do we have the double bond? On the second carbon, right? So that we would call this molecule, according to IUPAC rules, 2-octene. Now you can also write it another way if you wanted to, so I'll say or. You can say oct, and then in the middle you can say dash, then you designate what carbon number the double bond is on, which is 2, and then you finish off with the suffix "ene," because this compound has a double bond. Whichever way is correct according to IUPAC, okay? So according to IUPAC rules. All right, so that was our first practice problem, just an intro to octenes and naming it, and what correct ways are there to name it. So let's go to another example now. All right, so this is our other example. Let's start numbering it again. So again, you choose the longest carbon chain, and you want the double bond on the least carbon number, okay? So always remember that. So we number the longest carbon chain, okay? Let's write that a little better. Longest carbon chain, okay? But then you want, right, you want the double bond. Double bond should be on least carbon number. Least carbon number. So let's do that. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, and the reason why I didn't go this way is because we're trying to find the longest carbon chain. So if I went here, it would only end at 8. So right away that would lose because I have a longer option, right? So we wouldn't go the shorter option because we're trying to find the longest carbon chain. So we can do it this way, or why not just go back, right? But start from here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are the only two ways in which you can lead to 9 carbon chain, right? Because if we can't go this way because that would only lead to an 8 carbon chain. So out of these two main numbering patterns, which one should we choose? So again, we choose, just keep on looking at this rule that we've been working on. We choose the double bond that's on the least carbon number. So if we look at the red numbering first, at what carbon number does the double bond fall on, right? So for the red numbering, we're going left to right. So what's the first number in which the double bond starts? 5. So the double bond is on the 5th carbon. But for the blue numbering, what carbon number does the double bond fall on? Blue numbering, we start here. So if we're going, right here is the first carbon where the double bond falls on. So that's carbon number 4 for the blue numbering. Okay, so is 4 less than 5? The answer is yes, right? So we choose the blue numbering. Okay, so let's go ahead and draw that in, or erase the red numbering, right? And there we go. So the blue numbering is the correct numbering. Now we just have to name the molecule. So what are we working with? What substituents do we have? We have a 2-methyl, right? Because we have a methyl group off the 2 carbon. So we have a 2-methyl. And then we have a 3-methyl also. Let's go and write that down. We have a 3-methyl also. And then how long is our longest carbon chain? 9. So we have a non as our prefix. But would it be a nonane or a nonene? Right? Remember alkanes versus alkenes. It would be a nonene. Okay? And it would be, so let's go and write that down. It would be a nonene. And why is the suffix ene? Okay? The suffix is ene because we have a double bond. So we just put everything together. So the name would be 2-methyl, 3-methyl. So if there's just 2 methyls, we just call it what? What's the prefix for two of the same thing? We would just say di, right? Dimethyl. Because remember mono, or let's write that in a different color. Mono versus di versus tri, right? If you remember those, we would choose di this time, the prefix di, because that's 2 of the same thing. So it would be 2, 3. Okay, let's write the actual molecule down now. 2, 3, dimethyl. And then, on what carbon number is the double bond? 4, right? So we'd say 4 nonene. Now remember, in our previous slide, there was 2 ways to write this according to IUPAC. You can also say 2, 3, dimethyl, non 4-ene. Okay, that would be the same thing, and that would be also correct. All right, let's do 1 or 2 more practice problems. So let's do another one, and this is our problem that we're going to work on. So let's again start by numbering the longest carbon chain with the carbon number, or with the double bond on the least carbon number. Okay, so if we start off by numbering this longest carbon chain, we can start here, right? Where do we start so that we get the longest number carbon chain? Let's start here. 1, 2, 3, 4, 5, 6, 7, 8. So that would be 8, right? And then can we also start here in the beginning? So 1, 2, 3, 4, 5, 6, 7, 8, right? Or I mean, remember, you can go either way. 8 can be here or here, doesn't matter. All right, so these are the 2 main ways that we can get the longest carbon number chain. So which pattern is correct? Again, right? If we're looking at the green, which carbon number for green does the double bond fall on? Well, green numbering starts here. If we go, what's that? The first carbon that we see the double bond originate from, that's the carbon number that the double bond falls on. So that's 6. Okay, we do the same thing for blue, the blue numbering. All right, so the blue numbering starts here. So we oh, right here. So what's the first carbon that the double bond originates from? That's carbon number 2 for the blue numbering. So is 2 less than 6? The answer is yes. So we would choose the blue numbering, which would be this. All right, and from here, once you have the numbering, right, the numbering pattern that we need, you just name the molecule. So what substituents are we working with? We're working with 2 methyl substituents. Okay, so we're working with here, a methyl substituent there, and a methyl substituent here. All right, so if we were to name this molecule, we have a 5-methyl, and then we also have a 7-methyl, And then what's our longest carbon chain is 8, so we know the prefix is oct, but we have a double bond, so the whole thing would be octene with the prefix and suffix combined, right? So we just put everything together, and again, remember mono versus di versus tri and all that, right? So what do we have? We have two of the same substituents, 2-methyl, so we'd use di. So we would say 5,7 dimethyl, 5,7 dimethyl, and then you can say dash, right, dash 2 octene, because this number right here signifies what carbon number the double bond originates from, which is 2. Or, according to IUPAC, you can also say, right, 5,7 dimethyl oct 2-ene. That would be the same thing, and also correct. Now, you may also be wondering, right, why can't we name it so that we have an isobutyl group? So why can't we, number it. Why can't we number it so that we have an isobutyl group? Because then this way, if this were to be correct, which it's not the correct numbering pattern, we would have what? 5-isobutyl, 5-isobutyl, right? Hex 2-ene, or as we know, we can just say 5-isobutyl 2-hexene, right? Because that's also correct according to IUPAC. But this naming is obviously not correct, right? I'm just saying it as an example. You cannot number this molecule like this, because not only do you have to choose the carbon, the least carbon number in which the double bond is on, and not only do you have to choose the longest carbon chain numbering, right, which isn't 6, we saw it was 8, but you also have to choose the carbon pattern, the carbon numbering pattern, right, that has the most substituents on it. So if you compare this, you only have one substituent, right? But if we went and numbered it like we did the correct way, which we already did, right? 1, 2, 3, 4, 5, 6, 7, 8. Not only is this a longer carbon chain, so you'd immediately choose the red numbering, but even if you're looking at the number of substituents, the red numbering has more substituents. Okay, so that's one thing you're looking for, is which carbon numbering pattern has more substituents on it. Let's write that better, substituents. Okay, and we can easily see that the green numbering only has one substituent, but the red numbering has two substituents, methyl, methyl. And that's basically it for this video, and we'll look at more examples in the next video. So I hope to see you guys there.